Hi guys, one of the most important things that we as scientists do is to classify things, right? We put things into different categories based on shared characteristics. And as chemists, we look at the world in terms of teeny tiny particles. We look at the particles of matter, and matter is anything that has mass and occupies some amount of space. So we say that matter has mass and volume. And matter comes from the same root as material. So all material things are made up of some amount of matter, right? They're made up of some amount of stuff. They take up some amount of space. And we can talk about different things when we're classifying matter. We can talk about their physical state. So if we're talking about the physical state of matter, we're talking about their different phases or states of matter, which are solids, liquids, and gases. And if you've taken some science classes before, you probably also know that there are some other physical states, such as plasma, for example, which is kind of this supercharged kind of fluid, which is sort of a weird thing. But we as chemists focus mostly on solids, liquids, and gases. And we're thinking about the characteristics of those. We say that solids are rigid, right? They have a fixed shape, meaning unchanging. It has a fixed volume, so it takes up the same amount of space. Liquids are more fluid, so they have a variable shape. They take the shape of the container that they're in, but they always take up the same amount of space. So if I have my coffee cup and I trip and I fall and I spill my coffee, then it was coffee cup shaped when it was in my hand, and it's now puddle shaped when it's on the ground, right? So it's changing the shape, but it takes up the same. It's still a venti amount of my coffee, right? It's still 20 ounces. Gases are also considered to be fluids. So fluids are anything where the particles can move past each other. They flow past each other. So gases and liquids both flow, and they can take the shape of the container they're in. So the gases from our atmosphere takes the shape of the container of a room, for example, or a canister if we're going scuba diving. And they have a variable volume, which means, like in my scuba diving example, that I can compress them, right? I can compress them down into a teeny tiny space. I can expand them outwards as well, and they will fill that space. So it has a variable volume. Now we can change the physical state. We can go from a solid to a liquid or a liquid to a gas, and we call that a physical change, right? So we're just changing the state of matter, the phase of matter. We're not changing the chemical composition. It's still water. If we take water for an example, if I have solid water, that's ice. If I go from a solid to a liquid, we call that, melting. And now I have liquid water. If I go from liquid to a gas, that's called evaporating or vaporization, because gases are also called vapors. It's called a vapor when the substance is normally in the liquid phase. So, for example, water at normal conditions, at least on Earth, is in the liquid phase. It's actually in all three phases on our Earth at any given time, but at room temperature, under standard conditions, it's a liquid. So we have to do something to it. We have to put energy into it to make it into the gas phase, and we would call that a water vapor, for example. And we can go in the other direction too. We can phase change in the other direction. We can go from a gas to a liquid, right? And that would be condensing. Kind of like the steam from our shower would condense onto the mirrors. And then liquids can go to solids when we freeze them. So those are terms that shouldn't be too unfamiliar to you. Sometimes when we go from a solid to a liquid, we also call this fusion. So fusion is also melting. And when we go directly from a solid to a gas, so if I go directly to a gas, do not pass go, do not collect $200. This would be like carbon dioxide, for example. It sublimates, sublimation, or sublimating if I'm continuing with my English there. So sublimation. I've heard gas going directly to a solid is called also condensation, which is sort of annoying. And depending on the process, it's also called some other things. And we can get into that when we talk about the different phases in a lot more detail, which we're going to do next quarter. So we'll get into the detail of the individual phases later on. Now, a physical change can also include dissolving. So if I dissolve salt, sodium chloride, into water, then I didn't change the chemical composition of either one of them. I just changed the physical nature of what happened, right? I just dissolved it. And again, we'll get into more detail about what that means in the chemistry beside about solutions and dissolution a little bit later on. But that's also considered in physical changes. Now again, we're not changing anything about the chemical state, the chemical composition of the thing. And so now if we're classifying matter, it's important to know what phase it's in, but it's also important to know what it is. And so that what it is the chemical constitution. So what constitutes this chemical? Is it an element? Is it a compound? Or is it a mixture? And an element cannot be broken down into simpler substances. It's really, in a chemical sense, the individual building blocks that make everything up. So when we're talking atoms, that's kind of a fundamental unit in terms of chemistry, but really chemists care about elements, and we'll get into the periodic table of the elements a little bit later on. So an element is a substance that cannot be broken down. So an element is a substance, and that has a particular scientific meaning. We also call that a pure substance. A compound is also a substance, and that's where we have two or more elements that are chemically combined together. So this is also a substance. And I have a video on pure substances versus mixtures where we get into a little more detail on those, and so check that out if you want some difference here. So substances are elements and compounds. A mixture is more than one substance. So if we're thinking about some examples of this, give me a little more space here. Then an element could be something like, let's take gold, for example. The chemical symbol for gold is Au. So gold is an element. Elemental oxygen is O2. So it's what we call diatomic, meaning that it has two atoms that are chemically combined together. So the elemental form, the oxygen that we breathe, is O2. There's other ones that have greater numbers of atoms that are chemically combined together. Sulfur, for example, exists as S8. So that's sulfur. It is also an element, even though there's more than one of those sulfur atoms that are chemically combined together. And then compounds are two or more of these elements. So that would be something like water. So if we take our H2O, or if we take, I use salt in the original when I was talking about physical changes there. So that's sodium chloride. And we'll talk about naming conventions a little bit later on as well. So two or more elements, I can describe them with symbols. They're chemically combined together. They are compounds, but they are also pure substances. And then mixtures would be something like oil and water. It would be like my saline solution, right, which is salt water. So more than one of these elements or compounds that are not chemically combined together in terms of chemical bonds, but we've mixed them together in some sort of physical way. And that's the chemical constitution, what makes up that solution or that substance. Now, as opposed to physical changes where I wasn't changing the chemical constitution of it, in a chemical change, I'm really talking about a chemical reaction. So I'm changing from one type of matter into one or more new types of matter, or new kinds of matter here. So let's take, for example, iron. If I take iron and I sit it outside, right, then it reacts with the oxygen in the atmosphere and it rusts, right? We've all seen this happen. Some rusty farm implements, and the rust that forms is called iron oxide. I've chemically changed these two things. This is elemental iron with elemental oxygen, giving me iron oxide, which is a compound. So elements giving me compounds. That's a chemical change. It's a chemical reaction. I've transformed my matter from one type into another. So it's important to know not only kind of the physical properties of these things. Iron we know is a solid, oxygen is a gas, iron oxide is a solid, so that gives us the physical state of our matter, but it also, our chemical constitution gives us information about what is the change that these things are undergoing. How am I changing, going from one side of this to the other side? And again, we'll get into this in more detail when we talk about chemical reactions, but this is really just a summary of how we classify matter. So physical state, chemical constitution, and then within those, there's these different subcategories that we can use to describe different materials. And as always, if you have questions on this, don't hesitate to reach out. Otherwise, I will talk to you again soon.